Okay, first let me review some formulas. Okay, when you want to add up numbers from 1 to n, the sum is going to be n times n plus 1 over 2. Okay, and just for a side, suppose you want to add up 1 to, say, 50. Let's be 1 plus 2 plus 3 plus 47 plus 48 plus 50. I'm going to show you how they came up with this formula. What you can do to add these really easy is if you add the first and the last, you get 51. If you add these two, oh, I forgot 49. You get 51. If you add these two, you get 51. So how many times are you going to do that? You're going to get 51 since you're pairing 50 numbers, you have 50 over 2 pairs. So it's going to be 50 times 51 over 2. And that's what n is. N is 50 in this problem, so here's n plus 1, and you divide it by 2. And that's going to give you your sum. Okay, so this is the first formula that we're going to use. The second one is the I squared formula. When you're adding up the square terms, and you're going to get that. And those two you should know. The third one you don't have to know, but it's easy to remember. It's just this square. Okay, so let's we're going to use those later. Let's jump to a definition right now of what we're going to talk about today. And here's some conditions. F has to be a continuous function on an interval AB. Delta x is the width of the subinterval. And what we're doing is dividing AB, and we're going to get n equal subintervals. So that's going to be b minus a over n. So that's going to be your width. We're going to start out at a, which is x0, and go to the xnth interval endpoint will be b. So far we have x0, which is a, and xn, which is b, and we're going to divide them into n equal subintervals. Okay, so the width of this is delta x is b minus a over n. There's n equal subintervals here. And then we're going to let xi star be any point in the ith subinterval. And that's how we're going to get our height. So what we do is just pick any point, say here, this is the ith subinterval, and this point right here will be xi star. So when we draw our function, say this is going to be xi minus 1, and this will be xi. This will be the ith subinterval. We're going to pick the point, let's pick a point right here, xi star, and go up here, and that's how we're going to draw our rectangle. So this distance here is going to be f of xi star. That's going to be our height. Because this function is f of x. This point is going to be f of xi star. Okay, then what are we defining? We're defining the definite integral. So with these conditions here, The definite integral is defined to be the integral, that's the integral sign. This is the lower limit, this is the upper limit of the function. Then you have a dx is going to be the limit as n goes to infinity, I equal 1 to n, f of x I star delta x. That's the definition of a definite integral. Alright, let's go through each of those things. Now we have the limit. Let's see what each of these means. Okay, the delta x we said was the width of the subinterval. F at xi is the height of that subinterval, so this gives you the area of the ith rectangle. Height times width. F of x is the y value, so that's the height, and the delta x is your width. We're doing n equal subintervals. Then we're going to add up all the areas. And then we're going to let the the number of rectangles go to infinity. So what we're doing is, we got these rectangles here, and we're letting them go to infinity. And see, that's going to color in, that's going to be the area under that curve. That's going to give us everything, if the function's positive. Okay, now, a point I want to make, in the last section, so before, xi star was a left or right endpoint, or the midpoint of that interval. Now it can be any point in that interval. And this is called, you'll hear it called the Riemann sum. This definition right here is Riemann sum, named after the mathematician Riemann. Alright. When the function's positive, it means above the x-axis, then the integral a to b f of x dx is equal to the area under the curve f of x between the vertical lines x equal a and x equal b. If f of x is not positive, so suppose it kind of goes like this, then the integral a to b f of x dx, you can split it up, say that c is going to be equal to the integral from a to c plus c to b. Now this is below the x-axis, so f of x is negative, so that height right here is a negative, so I'll just say negative height. That doesn't make any sense, but that's going to be negative. So if this is area A and this is area B, then this is going to be A minus B, because this integral from C to B is going to be negative because it's below the x-axis. So what it represents is the net difference in the areas. Now when you take an integral, it's always going to equal a number. So no matter what, the integral from a to b f of x is equal to a positive or a negative number. You should always get a result. But if you're dealing with area, area is always positive when your function is positive, so you should get a positive number. When your function is not positive, you could get a negative number. And then it represents the difference in the two areas, the area above minus the area below. So your integral can be negative. Okay. Let's look at transforming some of these things. So if they give you, this is an example, if they give you, say, this problem, then that would really equal, say, the integral (0 to 3), because that's our interval. The function, this is f of x star, that's your height, so that's going to be square root of 9 minus x squared, and then your width out to x is your dx here. So that's the symbols that we use. So that limit right here, that sum, limit of the sum, represents this definite integral. So you may have to convert back and forth. Now, in terms of area, if we have f of x equals square root of 9 minus x squared, that means y equals square root of 9 minus x squared, and that gives you y squared 9 minus x squared, that gives you x squared plus y squared equal 9. Now that's a circle. So when you graph this, since we're only going from 0 to 3, 3 is your radius, it's just going to be the quarter circle right here. We want the area. And it's positive, so it does represent area. So area of a circle is pi r squared. This is a quarter circle, so it's going to be quarter pi r squared. So that's going to be a quarter pi 3 squared, which is 9/4 pi. So what that tells us is geometrically we can work this out. We don't know how to do an integral yet. And what this says is that the integral 0 to 3 square root of 9 minus x squared dx is 9/4 pi. Using a geometric argument. Okay, let's do the same thing with 1 to 5, 2x minus 1 dx. Well, let's graph it first. That's a line, so it goes through the point 1, 1, and 5, 9. So you could get this line. And since it's positive, it represents area. So we have the area of a triangle, which is 1/2 times base times height. And then we have a rectangle, which is just base times height. So let's say A plus B. So this is going to be the area A plus area B. And area A is a triangle, so it's half. The base is 4. And the height, since this whole thing is 9, and this is 1, the height's going to be 8. This right here is 8. And the base of the rectangle is 4 and the height is 1. So this is going to be half 32/16 plus 4. That integral should work out to be 20 using geometric argument. Okay, let's look at one more where the function isn't positive. So I want 3 to 7, 1/3 x minus 2 dx. So if I substitute 3 in there, I get -1. And if I substitute 7 in there, 7/3 minus 6/3 is 1/3. I get this. I guess I should have drawn a little bigger. Okay, so that's A and that's B. Now the area A, that's going to be negative, and B is going to be positive. Because your rectangles here have a negative height. They're under the x-axis. So this point right here is 6. So this is going to be a negative A plus B, because A is below the x-axis. And it's a half base times height because it's a triangle. Now the height is 1. And this is 3, so between 3 and 6, that's 3. Base is 3, so that's 3/2. It'll be -3/2. Okay, here, this is 7, so this is 1. It's a half, it's a triangle, so the base is 1, and the height is 1/3, so that's plus 1/6. So that's going to be minus 8/6, which is minus 4/3. So that just means the area below is bigger than the area above. So we do the area above the x-axis minus the area below. It's the net difference in area. So that integral should work out to be -4/3. So your integrals can be negative. All right, well, let's go back to Riemann sums. Now that we have more of an idea of what and we're going to use the right endpoint. If it doesn't say, just use the right endpoint. And we're going to have the integral 0 to 4 x squared plus 1 dx. Okay, so we have 0 to 4. So delta x, the first thing you should find is 4 minus 0 over n, which is 4 over n. So when you split this up, it's going to be 4 over n. The next one's going to be 8 over n, 12 over n. You keep moving by 4 over n. So this should be 4 over n I. It's going to be your ith interval, right endpoint of your ith interval. So that's, let's just say this. This is going to be 4i minus 1 over n, and this one's going to be 4i over n. If we use the ith interval. Well, we're going to use the right-hand endpoint. So let's just look at the sum first of all. It's going to be f of 4i over n, because that's the right endpoint. And our delta x is 4 over n. So I have 1 to n. This is f of x, so we plug that back in, and we get 4i n squared plus 1 times 4 over n. Now this sum only depends on I, so all the n's can come out front. So that 4 over n, this 4 over n can come out front. Okay, I'll just have to take a new page, but okay, I'm going to separate this out. So I'm gonna have that term. That's going to be 64n cubed 1 over n I squared plus 4 over n 1 I equal 1 to n. Okay, here's where I use the formulas. Remember, we have the formula for I squared. The formula for I squared is n plus 1 2n plus 1 over 6. That's what I squared is, from 1 to n. Okay, when you add up 1 to n, that's summation 1 to n, that's just n. So summation 1 to n is n. 1 plus 2 plus 3 plus 4. Or that's adding 1 n times. Okay, so those are going to cancel. Okay, so I have 64, 6. Let's see, that's going to be 32 thirds. Now, what's going to happen here, so I took care of that, and then I'm not canceling, I'm just crossing them out because I took care of it. Now, when you multiply all these together, it's going to be a 2n cubed plus something n squared plus something n plus a constant, which I don't really care about. Because, okay, and then plus 4, let's just add that on. I don't care about it because this n cubed is going to go and divide all these out. So I'm going to have 32 over 3, 2 plus something over n plus something over n squared plus k, some constant, over n cubed. And the last step, the reason I don't care about those numbers is because the last step, when I take the limit, is then goes to infinity all this. Something over n plus something over n squared plus something over n cubed plus 4. These are all going to go to 0. When you have n in the denominator, those are all going to disappear. So the answer is going to be 64 thirds plus 4, which is 76 thirds. And that represents the area under the curve. Let's draw a picture of the x squared plus 1 from 0 to 4. Since the function's positive, that's going to be the area under that curve, 76 thirds. Okay, so that's how you do it using Riemann sums. Okay, and the last thing I want to talk about are some properties of integrals. I'll show you how to use those in the homework. First one is if your function is positive, and these are all on a, b, closed interval, then your integral from a to b is positive. If you have one function larger than the other function on that interval, then the integrals are going to be larger on that interval. So these are all just talking about interval a to b. If your function is between two values, a min and a max, then I can kind of estimate the integral to be between these two values. And that's good for estimation purposes, because sometimes you just don't want to find the interval, you just need an estimate. Now this makes sense, because if your function, let's say your function is like this. So this is your min, this point, and this is your max, and this, just in this example, this is your m. And your width, that's your b minus a, the difference. So your area, if we think of this in terms of areas, the area of that is m, the height, times the width. The area of this one so you can see the area that you want is between those two rectangles, because the little rectangle has height little m, and the big rectangle has height capital M, and your function's in between those two, so that should make sense. Okay.